statistics. I hope you printed out this copy off the website, and just please follow along if you want. You can always skip ahead if you can, or if you need to rewind, you can also do that. Welcome to the wonderful world of learning through video. So let me start off this statistics topic by looking at this question. So I've got a tourist. He's vacationing in Vancouver during the spring of 2012, and he asked this question: how many millimeters of rain does Vancouver usually get? Well, to find the answer to this question, I helped him out by recording rainfall in millimeters for 7 consecutive days in Vancouver. And the data I collected is as follows: 12 milliliters for the first day, 14, then 888, then 12, then 15. Yep, rain, 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 lots of rain. So how are you going to answer this question then? I hope you remember, and if you don't, that's okay, but there were 3 different ways of measuring what we call central tendency. Central tendency, of course, like the middle, okay? And I hope you remember, but if you don't, I think one of the first measures we always saw or learned about was the mean. And if you're curious what the mean actually means, it's actually the arithmetic average. Okay, and to find this arithmetic average, all you really need to do is really just sum up all the data points. So you sum up all the data points. And then after you do that, you divide by the number of data points. And in this example here, if we were to do the same thing, we just take all the data points, so 12, add that to 14, add that to 3 of the 8s, another 12 and a 15, and I think then we will divide by the number of data points. There are 7. Let's see what you get when you add them all up. I'll bring out my calculator. You can bring out yours too. About 12 plus 14 plus 8 plus 8 plus 8 plus 12 plus 15. That's 77. Divide that by 7. For those of you who can do that really quickly in your head, yes, the answer is 11. So I could say, on average, it rains, I guess, 11 millimeters per day in Vancouver. That's one measure. There's another one called the median. And this really is the middle number in your data set. Now, please be careful. Your middle number needs to be found after arranging all the numbers in order, okay? So the numbers in the data set must be in order. Doesn't matter if it's biggest to smallest, smallest to biggest, but it has to be in order. In this case, I'll put them from smallest to largest, so 3/8. Then I got a 12, another 12, a 14, and a 15. And so in this case here, you look for the middle number. I guess there are 7, so 1, 2, 3 that way, 1, 2, 3 that way. The middle number in this case is 12. Okay? So once again, it's the middle number, but arranged in order. Now you might be asking to yourself, okay, well, what if my list actually had an even number of numbers? So let's say I had this, 8, 8, 8. Let's do one more 8. And then 12, 12, 14, 15. So now I have 8 data points. You're asking, where's the middle? Well, the middle seems to be in between right here. Okay, there's the 4, there's 4. So the middle should be right about here. Well, there's no number there. So what you need to do is take the average of the 2, what we call middle numbers, and the average of 8 and 10, or sorry, 8 and 12. That would be 10. So in this particular example, the median would be 10. Even though it's not in the list, it would be 10. Okay? So that's just what you need to be careful of if you have an even number of data points. And the last one is called the mode. That's the most common. And so you look at your list, see which number comes up most of the time. And of course, this one is just 8. Right? So 3 measures of central tendency, trying to find out by given a set of data, what's the middle going to be, the center. So I'm going to ask you to take a look at this example now. And here we got annual incomes for people who work at Mega Metal. You've got one manager, which makes $80,000, one supervisor that makes $45,000, 3 mechanics, which $35,000 each, and 5 laborers, which make $25,000 each. I'd like you to determine the mean, median, and the mode for the payroll. Okay. Now, once again, if you can do this on your own, go ahead and do this on your own. Just double check your answer with mine. But if you need to actually listen to me as I go through it, then of course watch the video and go through it. Okay. Thinking about mean, we're going to add up all the numbers. So I'm going to take 80,000. I'm just going to be lazy, put 80K. I'm going to add to that 45K. Then there's 3 mechanics with 35,000. So write that 3 times. And 5 laborers. Okay, I'm getting lazy now. I don't want to write down 5 laborers, so I'm just going to go 5 times and $25,000. Okay, go ahead and do that. And then, of course, we have to divide by the number of data points. 1 manager, 1 supervisor, 3 mechanics. So that's 2 plus 3 is 5, plus 5 labor. There are 10 data points here. So go ahead and do that. And I think the answer should be, I believe, 35,500. Okay, that's the mean. Now, to help you calculate the median, I guess what I need to do is put things in order. So let me order the list first. I'll go this time from largest to smallest, so that's 80K. Then you have 45Ks, 35 3 times, and then also 25,000 5 times. Notice there are 10 data points in my list here, so I got to be careful here. The middle seems to be, let's see, 1, 2, 3, 4, 5. The middle seems to be these 2 numbers, and so to find the median here, I need to average those 2 middle numbers. 35,000 plus 25,000 divided by 2. Well, that's just 60,000 divided by 2, or how about $30,000? So if I were to use the median as my central tendency number, I'd say the middle would be 30,000. Okay, and let's quickly do mode. Well, that's the most common, so I guess that'd be $25,000, because that appears most often. So which measure of central tendency could be used to make the salaries look really high? Well, if you look at that, the highest number is the 35,500 from the mean. Okay, and if I were to say, well, which number do you think I should use if I want to present that these guys are making not very much money? Well, then I would probably use the mode, in this case, 25,000. And that's where people say, hey, statistics can lie. I say, no, it can't lie, but it can be used to get to your means. Okay. All right, so I hope you have an idea of what these 3 terms are now like. If you turn to the next page, I'm going to ask you, well, which measure most fairly represents the average income in the company? Well, once again, like I said earlier, it's up to really you. I guess if you are like the labor guys and you're trying to get more money from management, then probably using a low one would be preferable. If you're management trying to show these employees that, hey, you guys are being paid quite a lot, then maybe it's the mean. And therefore, I'll say here, hey, answers will vary. Okay? Answers will vary. And I'll say depending on what you want to convey. Okay. Now, I'd like us to take a look at some test results from 2 different groups of students now. Okay, so let's pretend these are 2 different groups of students. They have 10 each. Group A, my maybe great class. Group B, my not so great class. I don't know, we'll figure it out. But 2 different groups of 10 students are given the same test, and here are their results. Okay, so 66, I guess these are percentages. Brian 67%, so on and so forth. I'd like you all now to please determine the mean, median, and mode score for each of these groups. Okay, so go ahead, please, and try this. Okay, I'll say for group A, you need to find the mean, we'll find the median, and also the mode. Okay. And so for the mean for group A, I'm just going to take all those numbers and add them up. 66, 67. You can do this on your calculator too. I've got 72. Median, since the group is already lined up, so 1, 2, 3, 4, 5. Looks like it's in between those, so the average of 70 and 72 is probably 71. And the mode, in this case, the most common one seems to be 78, because I see 3 of those. Okay, that's group A. I'm going to ask you to try group B, please, on your own. I'm just going to write down my answers. You stop the tape and give yourself some time to work on it, please. And so now, taking a look at our mean, median, mode, it looks like group A and group B have the same scores. So using this idea of central tendency is fine, but does it really tell you much about this group? Well, I guess it tells you what the average or the middle will be, but I think these two groups are quite different. So in terms of the central tendency, is there any difference between the groups? I'll say no. No difference in the central tendency. Okay? The mean, the median, and the mode are all the same. Yet if I asked you to look at how are the scores spread around the mean in each group, well, what would you say there? Are they the same? Well, it doesn't look like they are. So how do we tackle that? Well, there's a few things we can use. There's one terminology called the range. And the range is really the difference between the highest and lowest score in each group. So the lowest data point. And so we can use that to try to help us describe the spread. I guess in group A, the largest one was 78, and the smallest one was 66. So we'll subtract that, and I guess the range is 12. Whereas in group B, the largest one, or the highest score, is 100. And Andrea, who got the lowest, was 49. So the range here is 51. Now that's one way of talking about the spread. And notice in this case, then yeah, we have differences in group A and B. But you might want to consider the extent to where the scores are spread around the mean. Okay, not just the highest and the lowest, because I might get one weird data point at the highest end or one weird data point at the lowest end, and that could affect it too. So what I want you to understand is we really need to consider this. We need to consider the extent to where scores are spread out around the mean. And there's a special name for that too, not the man, the mean, and that's called the standard deviation. Okay? And really this provides us info on what we call the variability not just what's the middle, but how far away from the middle the scores will be. Right. So how do we actually calculate the standard deviation, or the variability or spread of a data set? Well, I'm going to use the same data set, group A and group B. Well, if you're thinking about the spread, then someone might say, well, let's take each data point and subtract it from the mean to see how far it actually is away from the mean. And that's what we're going to do here first. We're going to do the deviations from the mean. So remember that the mean for group A was 72. So if I were to take each score and subtract 72, these are what I get. They're the deviations from the mean. So 66 minus 72 is negative 6. 67 take away 72 is negative 5. And I'll just write down the rest. Negative 4, negative 3, negative 2. And of course 72 minus 72 is just nothing. There's no deviation from the mean because it actually is the mean. 2, 6, 6, 6. Okay. Now you might be thinking, well, let's just find the average of these then. Let's add them all up and divide by 10. Let's see what we get. Okay, if that's what you want to do, we can do that as well. I'll take negative 6 plus negative 5 plus negative 4 plus negative 3 plus negative 2 plus 0 plus 2 plus 6 plus 6 plus 6. And it's 0. Well, how is that going to help us then? So I guess in this case, the sum of deviations, I'll say the sum of the deviations from the mean are really no use because it equals to 0. That doesn't help me as well. Okay? Bad. So I think the reason why this is an issue is because, well, of course there should be half the numbers to the left of the mean and half to the right, because that's what the mean actually is. The mean is the middle. So if we're taking the difference of them, yeah, you have an equal difference from the left to the mean and the equal difference to the right. So no difference. So in order to get rid of that those negatives here, what people have decided to do is, well, let's just square each of the numbers, because when you square the numbers, you remove the negative, and therefore we can now count up the actual positive values. So we'll take negative 6 and we square it. That gives us 36. Do the same thing with negative 5. That's 25. Then we have 16. And we have 9. 4. 0 squared is 0. 2 squared is 4. 6 squared is 36, 36, and 36. Now we can add up these numbers to look at what the sum of the squares of the deviations will be. This time we know it's not going to be 0, so that's a good sign. 36 plus 25 plus 16 plus 9 plus 4 plus 0 plus 4 plus 36 plus 36 plus 36. And in this case you get 202. And so that's good. We've actually added up all the deviations. Just like how you find the mean, then we have to find the mean of these squared differences. So we'll take 202. And how many data points do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we'll divide that by 10. Okay, that gives you 20.2. Just to let you know, once again, the 10 is the number of data points. And then how would you actually find this standard deviation? Well, remember how we squared things earlier? Well, we kind of did that on our own, so now we have to kind of undo that. So to undo the square, we take the square root. So we'll take the square root of that previous number, and we get approximately, I think, 4.5. Let me just double check on my calculator. Root 20.2. Yes, that's 4.49, so 4.5. And ladies and gentlemen, this is what they call the standard deviation, or I'll use SD. This is a number that represents the variability from the mean. So to find the standard deviation again, and I must preface this is the standard deviation of a population, meaning you have all the data points available to you. It's not a sample. Okay. In this case, I have all 10 data points for all 10 of my students. Well, the first thing we did was we did the following. We found the deviations, right? So leave some space, by the way. We found the deviations from the mean. That's the thing we did first, the numbers in blue, right? And then what did we do? Well, that wasn't good enough, so we had to square them, and that's numbers in red. So we squared the deviations. So then I'll say we square the deviations from the mean. And then we did this part where we summed it, so I'll say now it's the sum of the square deviations from the mean. And then to find the mean, we did the following. After we found the sum of the squares of deviations, we then divided it by the number of data points. And then we had to undo that square part, so we then took the square root of this entire number. And that represents the standard deviation of a population. Okay? Now, just as an aside, if you are looking for the standard deviation of a sample, okay, then there's one small change, and that's where you take the number of data points and you replace that. Okay, so in this case, replace the denominator with this. Okay, it's not the number of data points, but it's the number of data points, and you have to minus 1. Okay, and that's to do something with the degrees of freedom. I don't want to get into that. That's in a statistics course. But in essence, what you're doing is you're estimating one of these variables, and therefore the calculations say that you can't take all the data points. You're going to have to divide by not 10, but in this case it would be 9. Okay, you just subtract 1. But anyways, that's not for us. I just thought this was just an aside for those of you who are really statistically inclined. Okay, aside. But when you have a population, when you have all the data available, then you use this formula here in the box. All right, I'm going to ask you to try to calculate the standard deviation of group B. Okay, follow the same steps, and let's see what you get. Okay, once you found the deviations from the mean, once again, remember the mean was 72. We're going to take the squares. 23 squared, what's that? 529, 256, 169, 64, 9, 136, 36, 489, 784. Go ahead and add up those numbers. Did I do that right? 9, 136, 36. It's not 484. It should be 484. Oops. Oopsies. 22 squared is 484. Whoops. Let's try this again. How about 2368? The mean, of course, you divide that by 10 to 36.8. Standard deviation, the last step is to take the square root. Did you get something like 15.4? If you did, congratulations. Give yourself a pat on the back. And if you didn't, why don't you go back and see where you made your mistake. Now I did ask you a question over here. Hope you didn't forget it. It says which group, A or B, has the larger standard deviation? So in this case, I think the answer is obvious. If you compare the two numbers, it's B. Okay, B is the larger one. But what does this actually mean? A larger standard deviation means what? Well, really what you see here is there's more variability in your data set. So kind of describes the class. I guess group A or class A, all the kids are quite homogeneous. They all did pretty okay, average is 72, but they're all closer together. Where in group B, I've got these really big spreads. I've got students, and I go back to the first page here, who did really, really well, like Kayla and Jennifer, but really bombed, like Andrea and Barbara and Christine as well. So once again, you see that big variability in your classes. Okay? All right, well, I've helped you calculate it. Okay, calculate these things called mean and standard deviation. And now the question is, so what? What can the mean and standard deviation tell you about a data set? Okay. And before we answer that, I'm going to look at this idea called the normal distribution. The normal distribution is really something that's quite theoretical, so it's a mathematical construct. But it's really based on if you had a data set that was infinitely large. So let's say I had like lots and lots of people, and I'm taking all this data. Okay, once I've got this data, and there's so many of them, I can actually plot this data, and a nice little distribution actually comes up. Okay, there is a mathematical way to calculate it, but you'll need, I think, third or fourth year university math to do it. So hey, let's not go there. Also, because this is theoretical, there are just as many items and variations on one side of the middle line as the other. So meaning, if I have the average, because this is theoretical, you would expect that there would be an equal number of data points above the average and an equal number of data points below the average. Okay, and also because if you have an infinite number of data sets, everything should be around the average. You'll see most of the items should be around the average. So let's just quickly look at these properties of normal distributions. Now, every normal distribution is like this curve. We call it the bell-shaped curve. So you might have seen that before or heard that before. Bell-shaped curve. And each of these curves has a mean, which we use the letter mu. This is the Greek symbol, mu. And standard deviation, which is called sigma. Okay. Just Greek alphabets. Okay. So what I want you to understand is we've got this mean, or mu, which is always in the middle. Okay. And then we have the standard deviation, which is really the distance away from the mean. So this distance from here to here is called the standard deviation. Okay. And notice that the graph is bell-shaped. What we call the bell-shaped curve, and it's symmetric about the mean. So half the graph is to the right of the mean, half the graph is to the left of the mean. The total area under the normal curve, so if I were to ask you to look at all this stuff underneath the curve here, well, that's equivalent to 100%. Okay? And so sometimes what happens is people will say, well, what's the area under a normal curve between two values? So let's pretend I've got this value here that's called A, and let's pretend over here I've got B. So if I were to ask you to find the area under the normal between the values of A and B, what I'm really asking you to say is figure out the proportion or the percentage of the population that lies in between those two values. Okay, so really this is the percentage or the proportion. I can't spell proportion. P-R-O-P-O-R-T-I-O-N, or the probability, okay, that a data value in the population is between those two numbers. Well, more importantly here, we also know this from a normal distribution. It says for every normal curve, about 68% of the population is within one standard deviation of the mean. So if I were to once again plot the mean, and I were to go one standard deviation to the right, there's my one standard deviation, And then if I go 1 standard deviation to the left, okay, the area underneath here is approximately 68% of your data. Okay, so 68% data, this is kind of like the average. Okay, then if I were to go out further and go within 2 standard deviations of the mean, so let's go 1, 2 now, so that's 2 standard deviations. And once again, you do the same thing the other side, okay? 2 standard deviations. Well, now if I were to look at the area underneath the curve, I would have now included here 95% of all your data points. Okay? And then if you wanted to go even further, to go 3 standard deviations away, well, when you do that, 1, 2, 3, you've pretty much included almost all of the data points. The area here underneath is about 99.7% of the population. Okay? So you can tell by going 1 standard deviation away, 2 standard deviations away, 3 standard deviations away, how far you're away from the mean. You can see that by going 3 standard deviations away, you pretty much encompass all of the actual area, of the entire percentage of the population. Don't know if you guys read polls, but sometimes they say the results are accurate 19 times out of 20. Well, 19 times out of 20, if you do a calculation here, 19 divided by 20, that's equal to your 95%. So that's really what they're saying in the polls. Their results are accurate within 2 standard deviations. Okay, so 95% of the time, that's what that means. All right, well, I want to say usually if any of your data points are plus or minus 2 standard deviations away from the mean, that's really a concern. Okay, so plus 2, whoa, this kid is like off the charts. Minus 2 standard deviations, whoa, like really far behind. We've got some issues. However, in a classroom, you might not have that many data points, so therefore you really can't see that difference with plus or minus 2 standard deviations. So sometimes people will consider data points that are plus or minus 1 standard deviation away from the mean to be not average. And therefore, if they're more than 1 standard deviation away, that might be some concern. Maybe this stuff's really great or they're doing really well. Minus 1 standard deviation, that means you're 1 standard deviation below the average. Well, this kid could be pretty far behind. We better find out some ways to help fix this. So looking back at our 2 groups of students again, okay? Group A, recall we had a mean of, and I think it was 72, and the standard deviation, I believe, was, I think, 4.4. And in group B, and by the way, you can look at this back on, I think, page 1 and 2, I think the mean was also 72, but the standard deviation was 15.4. Okay. Well, what I'd like us to do now is see if we can actually sketch a normal curve to show the distribution of marks for both groups. And I'd like you to mark the values on the horizontal axis, okay, that are 1 and 2 standard deviations from the mean. So here's group A, and then over here we'll do group B. Try your best to draw a bell-shaped curve. I forgot to do it for you, my apologies. And then because the mean of both is 72, at that middle part, I'm going to put down 72. Okay. Now, you need to figure out the rest. So we want to mark the axis where there's 1 standard deviation, probably 2 standard deviations, and I guess we don't want the third one. Okay. 2, 1, 2. But I'd like us to figure out what these values are going to be. Well, because it's 1 standard deviation away, going from 72 to the next one, I'm going to add to it 4.4. So 72 plus 4.4 is just 76.4. And then if I want to get to 2 standard deviations, I'm going to add 4.4 again, so that would be about 80.8. So here's, once again, 2 standard deviations away, positively. If I want to go 1 standard deviation to the left, I'm now going to take my value of 72, which is the mean, and subtract my standard deviation of 4.4, and that gives me 67.6. And we can do the same thing again to find out that next value, which would be negative 2 standard deviations away. That's 63.2. Okay. All right. Do the same thing for B, and so we'll take 72. We'll add 15.4. Then that's 87.4. Remember, one standard deviation here is 15.4, okay? And then further on, one more. We'll take 15.4. And, whoa, 102. Okay, even though you might not be able to score that. Oh, maybe there are bonus marks, who knows. Okay, similarly going the other way, 56.6, I believe. 72 minus 15.4. And then also subtracting another 15.4, we're at 41.2. Okay. So I guess in this case is so what? Which students, or so what can the mean and standard deviation tell you about a set of data? Well, tell me this. Which students in each group should you be concerned about? Well, definitely the ones that are like with 2 standard deviations away. But I don't think anyone actually is in that region. If you look at group B, is there anyone greater than 102 and less than 41.4? Don't think so. Even in group A, is there anyone bigger than 80.8 and less than 63.2? No. So maybe in this group, instead of looking at those that are 2 standard deviations away, we should be really looking at those who are plus or minus 1 standard deviation away. Really, I'm not really concerned about those that are more than 1 standard deviation away, but in particular, how about the students, right? We should look at students who are less than 1 standard deviation away. Okay, so I guess that means in group number 1, how about any student with a score that's less than 67.6%. And I guess in group, I should say A, sorry, group B, how about any student with a score that's less than 56.6? Those are the students that I'm worried about. They are quite, I guess, below average. We should really focus and see what happened to them. All right, almost done. Why is this normal curve important? Well, it's the backbone behind different other norms that you see quite often, especially in standardized tests that you might find in psychoeducational reports. Percentile rank I've seen before, the Z scores, T scores I've seen before too, something called a standard score, and stanines, which aren't used very often these days, but they are mentioned in your textbook, so I guess they are used. And I'll describe to you how those all relate to this idea of the standard, or the idea of the normal curve. Okay, so I've got my normal curve here, and remember we have standard deviations. So this is the mean, which is like 0. You have no deviation away from the mean. Then we can go 1 to the right, 2, and then 3 standard deviations. I can go 1 to the left, which will be -1, then -2, then -3. Okay. Remember the ideas how between -1 and 1, that is 68% of the data. So if I were to chop that in half, if I take 68 now and divide it by 2, you'll notice that I guess 34% of your data lies between 0 and 1 standard deviation, and also 34% lie between -1 and 0. Okay. Thinking about 2 standard deviations away, don't know if you remember that, but that was 95. So 95, chop that in half, divide by 2. Okay, that's 47.5 for each half to the right. So I'm going to say this whole part here. Don't write this down right now, this is just for you, but this whole part here is 47.5. So I'm curious about this tiny part here, what that will be. And to do that, we'll take 47.5, subtract 34, and that's about 13.5%. So what I want you to understand here is that from 1 standard deviation to 2 standard deviations, this here seems to be about 13.5%. Same thing over here. Okay. And then when you do 99.7 between 3, I'll do the calculations here. 99.7. How about divide that by 2? That's half. Subtract 34. Subtract 13.5. That's about 1.35%, hey? Oh, sorry, not 1.35. Let's just subtract 34. Sorry. 34 minus 13.5. Yeah, 2.35%. Okay, that sounds a little bit better. So this part here is about 2.35%. And if you're curious what's left over more than 3, this little tiny bit down here, that's like about 0.15%. Same thing over here, that's 0.15%. Okay, so you rarely see data that is beyond 3 standard deviations of the mean. Okay. Now, why do I show you those? Because now I want you to take a look at the percentile rank. Okay. Pretty much once you're at 3 standard deviations above the mean, you're pretty much almost at 100, or I'll say 99.9 percentile ranking. Okay. And then at 2, well, that's about 98. Okay. I guess 0. What do you think 0 is going to be? Well, that's halfway, so that's 50. Then I guess 1 standard deviation would be 50 plus 34, which would be 84. Okay. Okay, so what do you think about percentile rank is if I say that you're 84, that means 84% of the population is below you. Okay, so for percentile rank, it's better to have a higher number. Right? 2 standard deviations above the mean, that means you're 98 percentile rank. That means 98% of the data is below you. Okay? 50 minus 34, I believe, is 16. So percentile rank of 2 is less than 2 standard deviations away from the mean. And this would be about like 0.1. Okay? So those are the range of percentile rank scores you'll get. Z-scores are actually the same thing as the standard deviation. So sometimes they'll give you a Z-score number, and based on a Z-score number, you can tell where they are on this normal curve. Well, they're exactly the same as the standard deviations. I've seen T-scores as well, and T-scores are like percentile ranks, but uh-oh, my computer froze, so here it comes. Okay. Whoa, strange. It's lagging. Okay, so T-scores, the middle is also 50. But then they go up by 10 units of 10, I believe. So 60 is 1 standard deviation, 70, 80 is 3 standard deviations away, 40, 30, and 20. So those are the T-score values. Then you might see something called standard scores, and for standard scores, the average or mean standard score is 100. And then if you go 1 standard deviation away, they'll use the number 115. Then there's 130, and there's 145. And once again, these are arbitrarily made, okay, by someone, and we use it. The last one is stanines, and if you read in the textbook, stanines actually give you a value between 1 and 9. Okay, and let me just see if I can get back the graph, because I want to see the graph, the visual. Hopefully I can see it with the stanine. Okay, now for a stanine, the average score is about a 5. So what I mean by average is somewhere in this region here. Okay. I think I probably wrote that too big. Let me just go a little bit smaller. About right about here. This region, yeah, that's the score of a stanine of 5. Okay, and then if you want a 4, then you're almost to 1 standard deviation to the left. This region here would be approximately like a 4, and this region here would be approximately a 6. So that's why they say if you get a score of 4, 5, and 6, you're kind of in the average, the middle part. Okay. As you branch out further, like this is like 7. And then the next part here is 8. And if you're 2 standard deviations away and beyond, then this is stanine number 9. Okay, so that's 9. Similarly, going the other way, here's 3. Here's 2. And if you are going to be to the left and like -2 standard deviations away, this is stanine number 1. So once again, kind of like the average, right? You got above average. Oops, I'll use different color. Yeah, undo. Above average. And here you got your below average, and then maybe over here you've got your superior. Maybe not so superior. Okay, so that's how they describe the stanines, and these are all based on the normal curve, and that normal curve is based on the 2 measures called central tendency, the mean, and the variability of your data set, the spread. Okay, knowing all these pieces of information, you should be able to now work on the assignment that will be given out in class.